Welcome back to part 2. I feel like an actual YouTuber, guys. I feel like I should be like, hit that like and subscribe button if you like this video. Anyway. All right, so geometric recursive formula. This allows you to find the nth term of the sequence. So let's see how they differ from the arithmetic sequence. We'll look at both of these, write the recursive formula for each. So this one right here is the geometric. This one is the geometric. And this one right here, this is the arithmetic. This is the arithmetic sequence or formula, recursive formula. So the first two give us what they are, and we'll have to figure out the last two. So this says that this is geometric, so let's find our common ratio. The difference here is 18. The difference here is 72. Difference here is 288. So I can take 72 over 18, and I get 4. And I can take 288 over 72, and I get 4. So common ratio is 4. So let's write our arithmetic or geometric sequence. I know that it's taking this form right here. So AN is going to be equal to, what's my common ratio? My common ratio is 4. And then I'm just going to write AN minus 1. Well, that's it. That's all you got to do. If you want to check it, let's try A2. So what should A2 be? Well, that would be 4, and then I'll plug in A2 minus 1, which is going to be 4 times A1. Well, what is A1? A1 is 6. So this will be 4 times 6, which is 24. Is 24 the second term in the sequence? Sure is. So I know that I did it right. All right, let's look at arithmetic. Arithmetic sequence, what's the difference here? 4. What's the difference here? 4. And what's the difference here? 4. What's one thing that I might be forgetting there? What's one thing that I might be forgetting? Well, is this sequence increasing or is it decreasing? It is decreasing, right? So this should be negative. These should be negative. Negative, negative, negative. All right, so then I need to write, so our common difference is -4. So then we're going to use this recursion formula for arithmetic, and this will be AN. And then we're just going to keep the AN minus 1, and we're going to do plus D, but in our case, it's going to be minus D, so it would be -4. And this is an A. Don't get confused. That's an A. So that's it. And if you wanted to check, let's try A2 again. So if we wanted to check, A2 is going to be equal to AN minus 1. Well, let's go ahead and plug in 2. And then this will be, oh my gosh, I'm just butchering this. Let's get rid of this. Oh no, come back. There we go. So this is 2 minus 1. And then this will be -4. So this turns into A1 minus 4. Well, what's the first term in the sequence? First term is 17. So this would be 17 minus 4, which is 13, which is the second term. Is that the second term? It is. So we know that this is right. Boom. All right, so now these next two, I don't know what they are, so we'll have to try and figure that out. Let's do difference here is 6, 15. Right away, I know it's either geometric or neither. I know it's not arithmetic because they're not the same. The difference here is 37.5. So let's check out the common ratio. This is 2.5, and 37.5 divided by 15, it's also 2.5. So I know that my common ratio is 2.5. 2.5. So to write a formula, AN is equal to R. What's R? Common ratio, 2.5 times A to the N minus 1. If we want to put that in parentheses, you can. If not, it doesn't matter. But that's my formula. And the last one, the difference here is 27. Difference here is 27. Difference here is 27. All the same, so I know it's going to be arithmetic, so I'm going to be using this one. So AN is equal to AN minus 1 plus 27. That's it. Not too bad, right? All right. Let's look at the last one. A real life example. All right. So the money that Ron has in his savings account earns interest each year. He does not make any withdrawals or additional deposits. The account balance at the beginning of the year is $10,000. And then it goes to 10,300, 10,609, and then 10,927 and 27 cents, and so on. Write a recursive formula and an explicit formula for the sequence. So I need a recursive formula and an explicit formula. So I need two things. All right, let's rewrite out the sequence. So this is our sequence. And let's check to see if it's arithmetic or geometric. So the difference here is 300. Difference here is 309. And the difference here is 318.27. So I know it's not arithmetic because the difference between here is 9. The difference between here is not 9. So let's find the common ratio. Let's see if there is one. So 309 divided by 300. This gives me 1.03. And if we check 318 divided by 309, this also gives me 1.03. So I know that my common ratio is 1.03. So if I wanted to write the recursive formula, all I would have to do is AN 1.03 AN minus 1. That's it. That is a check mark. But it also wanted an explicit formula. So the explicit formula is actually what we learned last week. It was that A equals your principal, 1 plus your rate to the t power, where t is the number of years. So what's my rate? Well, my rate is the same thing as your common ratio. It's that 1.03. And if you notice, this 1 is that one. Your rate is actually just this part right here. It's at 3%. You're getting a 3% interest rate for this particular bank or problem. P, remember this was, let's write these things out. This is your rate. This is your time. This is your start amount. So what did we start with? Well, let's see, A equals P 1 plus R to the T. So A, what did I start with? 10,000. And then 1 plus, what's my rate? Well, my rate is just this 3%. So I'll put 0.03, and this will be to the T power. Or if it just makes sense to skip that line and just write this one, this would be 1.03 to the t power. So it's kind of cool. This and this, these are the same thing. They'll give you the same answers. If you don't believe me, go try it out. So yeah. All right. Meet me in the next video.